Hi, 8th grade. This is Miss B here with lesson 410. Let's begin by going over our do now. So yesterday we did our first lesson on substitution, in which we took an equation that was set equal to y and substituted into the second equation. So in this example, we have y equals 2x plus 15. Since that is set equal to y, we are going to substitute it for y in the second equation. So as we went over in class, because we're substituting into the second equation, let's rewrite it with parentheses for y instead of writing the actual variable out. So now we're going to take 2x plus 15 and substitute it into our equation. So we have 2x plus 15 on the inside of the parentheses. So now as our first step, in solving for the solution, we're going to solve for the variable x. So we're going to distribute to get rid of these parentheses, and we have 4x plus 30 plus 4x is equal to 6. Combining like terms on the left-hand side, we have 8x plus 30 equals 6. If we subtract 30 on both sides of our equation, I'm going to continue on the right here. We have 8x equals 24, negative 24. Therefore, x is equal to negative 3. So now I'm going to take my value of negative 3 for x and substitute it to solve for y. So if x is equal to negative 3, we're substituting negative 3 into the first equation for x to solve for the value of y. So we have y equals negative 6 plus 15. Negative 6 plus 15 gives us a positive 9. So remember, you must write your solution as an ordered pair, and the solution is at negative 3, 9. Today's lesson is to solve a system of equations algebraically, and our focus today is on the number of solutions. So we're either going to have one solution, no solution, or infinite solutions. In this first example, we're going to have one solution. Each equation is set equal to y, therefore we're going to set the right-hand side equal to each other. So we have 7x minus 10 equals negative 3x. To bring our variables together, we are going to subtract 7x on both sides. And we have negative 10. Be sure to write the sign of the number in front of the number is equal to negative 10x. To get the variable by itself, we divide by negative 10 on both sides of the equal sign, and x is equal to positive 1. A negative divided by a negative is always positive. So the x-coordinate of our point is positive 1. Since both of these equations are in slope-intercept form, and we have y by itself, we can substitute 1 into either one of these equations to solve for y. So the second equation requires fewer steps, so let's go on ahead and substitute negative or positive 1 into the second equation. Negative 3 times positive 1 gives us a negative 3, so the solution for this first example is at the point 1, negative 3. Let's take a look at what happens when our system has no solution. So remember, in order for there to be no solution on our graph, we would have parallel lines. So the lines that we graph would never intersect. Parallel lines contain the same slope, but different y-intercepts. So just by looking at these two equations, we can tell that they're never going to intersect. If we were to solve this algebraically, each of these equations is set equal to y, so we're going to set both of the right-hand side of the equations equal to each other. We're substituting what we have for y into the second y. So negative 2x minus 8 equals negative 2x minus 12. If we were to solve this equation and bring our variable of x together, so if I add 2x on both sides, they're going to cancel out. And what we're left with is our constants. So we have negative 8 is equal to negative 12. Since this is a false mathematical statement, and negative 8 and negative 12 are not the same number, we put this line going down the equal sign, we put this line going down the equal sign to show that we have a false statement. Anytime you get a false statement, there is no solution to the system of equations. So this is an example with no solution when you have parallel lines. And the last example that we'll look at for today is a system of equations that has infinite solutions. So infinite solutions, we're looking for the same slope and the same y-intercept. So if we were to graph these two equations, we would get the same exact line. Using substitution, since the second equation is set equal to y, I'm substituting it for y into my first equation. So I have 2 times 5x plus 7 is equal to 10x plus 14. So let's go on ahead and try to solve for x. In order to eliminate these parentheses, we're applying distributive property. So we have 10x plus 14 equals 10x plus 14. So notice we have the same exact expression on both sides of our equal sign. If we try to solve for x here by eliminating negative 10x on both sides, these two terms cancel out and we're left with 14 equals 14. Since this is a true mathematical statement, we have infinite solutions. So anytime you get something that's true, it's infinite solutions. If you get something that's false, like in example 2, there are no solutions. For today's classwork, you have 50 minutes to complete numbers 4 through 11 for full classwork credit. The remainder of the handout will be done for homework. If you finish everything in class, you receive extra credit for classwork and for homework.